A Chaks solution. This is vector 2. In today's lesson, we are going to be dealing with finding the equation of a plane containing 3 points and showing that the line lies on the plane. Alright, so if we have a plane that we have here, and we have 3 points that are on the plane A, B, C here. So you can see A, B, C are non-collinear points, which means they are not lying on the same line here. So we can find this equation of the plane. So what we just need to do is to choose our central point here. So we can choose A and find the vector AB and also find the vector AC. So the next thing now, we can cross the vector AB and CAC such that we can get the normal vector here. So what we are saying, the normal vector is equals to AB times AC. Alright, so now let's look into the question that we have here. Alright, so you can see the equation. They are saying find the equation of the plane which contains points A, B, and C. Alright, so the first thing here, we can find the vector AB. Alright, so vector AB is OB minus OA here, which is our OB minus OA. Then we are going to have 1, 0, minus 2. Now we can also find vector AC. So vector AC is OC minus OA, which is OC minus OA. We take vector OC minus OA, which is going to give us minus 2, minus 1, 0 here. Right, so now we need to find the normal vector. So the normal vector is now equals to AB cross AC, the cross product of AB and AC. Alright, so by now I know you are now familiar with the cross product, so that will give us the normal vector here. So the normal vector is minus 2i plus 4j minus k here. So if you haven't watched video on vector cross product, just go and watch the video on vector cross product so you can understand all these concepts on the cross product. So now we have the normal vector here. Alright, so now to write the equation of a plane, what we need, we have the normal vector, and we also need the fixed point in the plane here. So the fixed point in the plane, you can take A, B, and C. We are going to use this equation of a plane, which is r dot normal is equals to A dot normal. So which is r dot, the normal vector is minus 2, 4 minus 1 is equals to, then we can now take a fixed point. So the fixed point, we can take 1, 2, 3, which is our fixed point, or we can use 2, 2, 1, or you can use minus 1, 1, 3 here, dot the normal vector. So in this case, we use A, which is our fixed point. Then we do our dot product on the right hand side here. So we are going to have r dot the normal vector minus 2, 4 minus 1, which is equals to 3 here. So that's the equation of the plane. But remember, the equation is saying find the Cartesian equation of the plane. So this is the vector form. So now we can write it in Cartesian form. So r is just a general point here, so we can put x, y, z here, dot the normal vector is equals to 3. Then we now do the dot product. So this is going to give us minus 2x plus 4y minus 4z is equals to minus 2x plus 4y minus z is equals to 3 here. This is now the equation of the plane in Cartesian form. Alright, so now let's go. Alright, so this one, they are saying show that the line with the vector equation of r is equals to 2i plus 2j plus 6k, which is our fixed point in the plane here, plus t, the direction I, plus 3k lies on the plane pi r dot the normal vector minus 3 minus 5i is equals to minus 10 here. Alright, so let's see here. So you can see this is our plane here that we have, and this is our line which lies on the plane. So if the a line lies on the plane here, it means all the points, they also lies on the plane here. So what we just need to do is to substitute this line into the plane and see whether it satisfies the equation of the plane, or is all the points on the line here are consistent with what, with the plane for any value of the parameter here. Alright, so we are just going to do this. So this is our line, this is our plane, r dot the normal minus 3 minus 5 1, then equals to minus 10. Then r is equals to, this is the fixed point 2, then 6 here, plus lambda 103 here. So now this is the line that we have. So if we substitute this line into the plane here, if the line lies in the plane, it means the line here, all the points on the line must be also in the plane here. So the line must satisfy this equation of the plane here, or the line must be consistent with the equation of the plane, right? So let's see. All right, so this is the line that we have. Our line is 2 plus lambda, then 2 minus 0 lambda, then 6 plus 3 lambda here. Put it in place of r, dot the normal vector, which is minus 3, minus 5, 1 here. The answer should be equals to minus 10. Then we are going to perform our dot product, so it's minus 3 times 2 plus lambda, then plus minus 5 times 2 minus 0 lambda, plus 1 times 6 plus 3 lambda here. The answer should be equals to minus 10. So now we simplify. This is minus 6 minus 3 lambda minus 10 plus 6 plus 3 lambda is equals to minus 10 here. So you can now see minus 10 is equals to minus 10. So for any value of the parameter here that we are going to put, it means all of the points, they are on the plane. So the points which are on the line, they are also on the plane, which means the line lies on the plane here. So since the line is consistent for any value of the parameter, the line lies on the plane. So therefore we have proved that, or we have shown that the line lies on the plane. Right. So now you can practice question 1, question 2, and question 3. If you have any challenge, feel free to kindly contact me on my contact number, which is below. Yeah, thank you for watching the video. See you in the next lesson.